In this lesson, we're going to look at using the factor theorem, which is a theorem that we can use to help us solve equations that could not be solved by factoring. But first, before I show you the theorem, let me ask you a question. Is 5 a factor of 42? I think you'll tell me that no, 5 is not a factor of 42, but why not? You know that 5 does not go evenly into 42, and you know that because when you do 42 divided by 5, you get a remainder. So we have this connection between a remainder and a factor. If you do the division and you get a remainder, then whatever you divided by is not a factor of whatever you divided into. If we ask is 12 a factor of 72, then we say yes, because 12 goes evenly into 72, because when you do 72 divided by 12, you don't get a remainder. So yes, 12 is a factor of 72. And so again, we see the connection. If you have no remainder, it means that whatever you divided by was a factor. So if you can say that x is a factor of y, that's the same thing as saying that y divided by x has no remainder. They both mean the same thing. So now we can think of this in relation to functions instead of just numbers. We know how to do synthetic division that shows whether x minus c can be divided evenly into f of x. Well, if x minus c is a factor of f of x, that's the same thing as saying that f of x divided by x minus c has no remainder. And if it has no remainder, that's the same thing as saying f of c equals 0. And we know that because of the remainder theorem. That if we divide using c in the box for our synthetic division and we get 0 as a remainder, then f of c equals 0. So all these ideas in blue all mean the same thing. They're all interchangeable. In other words, if you know one of them is true, you automatically know the other two are true. And by the way, if we know that f of c equals 0, then we say that c is a 0 of the function. That's what it means to be a 0. It means that if you plug c into the function, it makes the function add up to 0. So here's the type of problem that we might see in this section for this theorem. Solve the equation 2x to the third minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of f of x equals 2x to the third minus 3x squared minus 11x plus 6. So they have to tell you the equation and they have to tell you one of the zeros. Now we're going to use the factor theorem. If we know that 3 is a 0 of this function, that's the same thing as saying that x minus 3 is a factor. Remember, if plugging in 3 to the function gives you 0, it means that x minus 3 is a factor. And if x minus 3 is a factor, there must be another factor that we don't know about yet. So if we do the synthetic division using 3 in the box, then this is the answer that we get. That means that our equation, which used to look like this, is now going to be broken down into 2 factors. The x minus 3, because that's what we divided by, and the other factor is here. So now, one of the solutions to this equation is here, and the other 2 are wrapped up in this trinomial. So if we start to factor this trinomial, we know that 2x times x is 2x squared, and we know from here that the signs should be different, and we know that last times last has to be 2, so it must be 1 times 2. And now you always have to check that outer plus inner makes the middle term that you wanted, and it does. 4x minus 1x is 3x, so this is the correct factoring, and each of these parentheses is going to give us a solution. If x minus 3 is 0, then we see that x must be 3. Of course, we knew that already was a solution. And if 2x minus 1 is 0, then x equals 1/2. That's another solution. And if x plus 2 is 0, then x equals negative 2, and that's our third solution. So those are the three solutions to this equation. Now let's look at a new example. Let's solve the equation 2x to the third minus 5x squared plus x plus 2 equals 0. And I just want you to realize that this is an equation that we would not have any other way to solve if they didn't give us a 0, because the degree here is too large for us to factor it except for any other way besides grouping, and our grouping method does not work here. So they have to tell us one of the solutions. Solve the equation given that 2 is a 0 of this function. But notice this function is the same as the left side of the equation. So really, 2 is a 0 here is the same thing as saying that 2 is a solution of our equation. They're interchangeable. So now, if we know 2 is a 0 of this function, then we know that x minus 2 is a factor of this expression. And we have to find the other factor. And we'll use synthetic division to find that other factor. So I'm going to put 2 in the box. And there are all my other coefficients, and I'm trusting that you remember how to do the synthetic division. So now, if we've divided by x minus 2, we've broken our equation down into two factors. X minus 2, and the other factor comes from 2x squared minus 1x minus 1. Now, this trinomial contains two of our solutions, so we have to factor it to find out what they are. And I've already done the factoring here, and you can just check that outer plus inner is going to add up to negative x, and so this factoring is correct. And now we're going to get a solution from each factor. The first factor gives us a solution of 2, which we already knew. The second factor gives us a solution of negative 1/2. And the third factor gives us a solution of x equals 1. So those are our three solutions, 2, negative 1/2, and 1.